Here we're taking a look at using a graph in order to factor a polynomial. So our first polynomial is a cubic. We want to use this graph to factor the polynomial f of x, where f of x is equal to negative 1/2 x to the third plus x squared plus 1/2 x minus 1. Couple of things we want to note immediately. I notice that this is cubic. I notice the odd end behavior. First thing I need to know, what's my leading coefficient? Notice this is a decreasing function. Should not be a surprise because our leading coefficient here is negative. In fact, it's a negative 1/2 coming from that cube. That will play into our factorization. The second thing we'll be able to take advantage of are what are the zeros of our graph. From the graph, I can see that our function hits 0 3 places. At negative 1, at positive 1, and at positive 2. So we actually have 3 zeros. Negative 1, positive 1, and positive 2. The question is, where did those zeros come from? Our general factored form, we're going to take advantage. And you could think about it this way. When we were solving to find zeros, I know, for example, if x is equal to negative 1, and I happen to add 1 to both sides to this equation, then x plus 1 would be equal to 0. So the fact is, if we know a 0, x minus whatever that 0 is going to be one of the factors. So for this function, we're almost done. F of x would be equal to, first, the negative 1/2. That comes from our leading coefficient. We have 3 zeros, we will have 3 factors. From the x minus a negative 1, we get our x plus 1. From our 0, x equals 1, I would have the factor x minus 1. And finally, from our third 0, 2, I know I'm going to get the factor x minus 2. And so we have a completely factored form for f of x. That worked nicely. We can now turn our attention to another function, g of x. This happens to be quintic. It is to the 5th power. And I notice that odd end behavior. On one side, one direction. On the other side, another. I do notice it's decreasing, which makes sense because our leading coefficient is a negative 1. So that's the first thing I noticed. What is the leading coefficient? For us, our leading coefficient was a negative 1. Now the other question is, where are our zeros? Notice our graph hits 0 at negative 2. But when I take a look closer, a little snapshot around this thing behaves like a parabola. I actually see it bounce. That gives us our multiplicity. So we have a root at 2 with a multiplicity of 2. It behaves like a quadratic, behaves like x squared. I have another 0 where x equals 1. Now, taking a snapshot of this guy, this is not linear. It looks like it does a little dance through. Hey, that's what x to the third behaved like. So here we have a 0 at 1. It has a multiplicity of 3, which makes me feel really good because something squared times something to the third would indeed give me something to the 5th. I think we have all our pieces. We can take a look at a factored form for g of x. Starting again with the leading coefficient, g of x is negative 1 times. I had a 0 at negative 2. X minus a negative 2 would be the same as x plus 2. It behaved over here like a parabola So we will use our multiplicity of 2. This must be x plus 2 quantity squared. Also, we had a 0 where x was equal to 1, so I will have a factor, x minus 1. But over here on our graph at 1, it was not a straight line through, it gave a bend. So it behaved like something of multiplicity 3, like a cubic. So I will have x minus 1 to the third power. Makes me feel happy because I definitely have a degree of 5 for this factorization. Looking good.